Hi everyone, I'm PP Jones, Director of Financial Services at Confluent. And today we're going to take you through why I think data streaming and data streaming platforms are a crucial part of the future vision for financial services, and how many of our customers today are on the journey or have already begun taking advantage of the capabilities of data streaming and event-driven architectures to help streamline and improve the services and capabilities that not only they offer their customers, but their internal customers in the company as well. So their business users, to enable them to have far greater access to the data that's stored within the systems and available to them, but in a way that reduces replication and helps cut down on the time to get something up and running and available to those internal customers, as well as, of course, the external customers. But before we start, I thought it'd be a great idea for us to set the scene generally on data streaming. And to do that, I'm going to take advantage of a video that was used to kick off our recent event in California at Current 2023. And I'll let that do the talking initially, and then I'll be right back as soon as that video's finished playing. Here we go.
If it weren't for our imaginations, life would be flat, one-dimensional, without newness or next gen. But we're gifted with the power to wonder and question, reason and imagine, reimagine, reshaping one thing into another. In the data streaming era, life is happening at dizzying speed. Blink, and something new is here. An idea becomes a project, becomes a prototype, becomes a product, becomes the game changer in record time. We're faster, infinitely more agile because of streaming data. Shared streams are widening innovation's footprint and changing the landscape everywhere. Data silos are disappearing into the stream. Smarter data is emerging. Computers are creating and thinking, and that's just the beginning. Real-time decision-making is happening. Together, as wanderers and solvers, we're transforming what data can do in ways we used to only imagine. The future of data streaming is happening now. Reimagine reality, then make it happen.
Obviously, what we're really talking about there is taking advantage of data and analyzing the data and processing the data as soon as it becomes available in such a way that we can take the most advantage of not only the time, but the interesting combinations of the data from the various different sources that we can create, perhaps in the form of data products sitting right there inside the stream as the data is in flight. So with that in mind, let's just extend that conversation in the video, talked a little bit about of all the wonderful things that we can do, and just remind ourselves of the journey we've all been on over the last few decades. So when we first, thinking about flagging taxis, for example, you'd go out into the street and you'd try and just grab a cab. Certainly in London and New York, that's very much the case in many cities around the world. But of course, in the modern era, you now have an app, and that app will allow you to not only, well, in fact, many apps, and those apps not only allow you to choose between the different services that are available, but also the different type of cars that are available, what things you're looking for from a comfort level, the number of people you want to take, the length of time you want to wait, and how much you want to pay. So that's all changed so drastically from only a few years ago. It's the same with shopping. You might go to the store, and certainly you might still today collect most of your fresh vegetables from the shop directly, but many people take full advantage, especially due to their experiences during COVID and lockdowns, of doing their shopping directly from either the apps they have on their phones or from the websites that they have access to for their chosen retailers, to have deliveries put straight in bags and down to their front doors. And in the future, of course, that's, as we already know, being experimented with around the world. Many things like that might even be delivered in automated ways through robots and drones. And then, of course, at the far end, for those of you who've never seen one of those before, that is a check. And certainly when I first started work, it was the primary way that I was paid. And I would, if I was able to get to the bank in time that day before it closed, I would take that check, I'd pay it in. And if I was really, really lucky, within about 5 working days, I might have that money available to me in my bank account. And then I'd have to go to the bank physically and check. But of course, check that was actually in the bank account. But of course, today, it's much more likely that things happen automatically. You get paid directly into your bank accounts. via some method or another, and you will be able to go into an app or to your website somewhere your bank supplies you with to look at the balances and even do transactions and make payments. And of course, everybody utilizes facilities like that nowadays, so they don't even have to carry their cards around with them anymore. You can just pay directly from the device that you use. When you're at some kind of retail outlet buying, say, let's for example, coffee or anything like that, right? So, of course, we're all very familiar with all of those things. But we do need to think about the evolutionary journey. And I don't think it's transformation I'm after, it's the word evolution. So I tend to use this as a way to just remind ourselves of the journey we've been on in the technical landscape over the last few decades. And one of the things that you do have to think about when things are evolving in any ecosystem, but specifically in technology, is that you tend to move as fast as the things that you still have running. So when you have legacy systems, when you have systems that were put in place many decades before, then it's obvious that there are some things that are going to take you longer to evolve, and that's okay. If you approach things in a phased approach, you look at the most serious things you have to solve first. You look at ways to solve those as a priority, and over time you might phase out some of the older systems, replacing them with newer ways of doing things, and that's perfectly acceptable. But do remember that some of the fundamental building blocks of today's technology come from limitations we had with hardware when we first started on these types of journeys in the late 70s and early 80s in business. So with that in mind, let's remind ourselves of the common concept of and well-known concept of data at rest, or DAR, which a lot of people often refer to it as. It doesn't sound so nice, but anyway, the idea of data at rest, very simply, is that fundamentally you would pick up information, you would gather it over a period of time, perhaps, and put it into files somewhere on a disk, and then you might lift it and load it and put it into a database, converting it into whatever format you want. And obviously databases then allowed you to search for things in a fairly straightforward way using some sort of syntax, maybe SQL type syntax or SQL type syntax, if you're more familiar with it being called that. But how did that all come about? Well, the majority of the main reason for the majority of databases that came out into the marketplace in the early 80s was because of the cost of the hardware. The hardware itself was incredibly expensive. So there's, of course, in order to store as much useful information as you could, you had to find a way to reduce the data and the information down. So things like timeliness and changing events, that was a secondary factor back then. You'd be much more interested in saying, well, okay, what can I store and how much of it can I store? And is there a way I can relate it together easily to locate that information again later and try to serve some usefulness from the data that I have managed to store and keep track of. So it's no surprise that we came up with what was effectively the theoretical database model, or theoretical models for databases. And most of the time when you were building databases, you would go through some kind of process of normalization to some level. And that normalization process would allow you to create objects like tables, and those tables would be structured to solve the problem of having too many duplicates of different types of data all the time, but allow you to join them together to create the duplicates when you needed to for the purposes of trying to query things. And that's all fine. Of course, that makes perfect sense, because, of course, the limiting factor was the hardware, as we all know. So let's just go and remind ourselves of the kind of hardware we're talking about. So those of you who haven't seen this before, this is one of the considered to be the first portable computer that came into the marketplace commercially around about 1981. Of those of you who are thinking that doesn't look very portable, you'd be quite right. I do remember seeing one of these a few years later when I first began work, and I did pick it up, and it wasn't at all portable. But at least I didn't think it was. It was very heavy, and it was actually quite fragile, I felt, as well. But remember, it was a pioneer. It had a keyboard, it had a sort of cathode gray tube in the middle. It had some limited graphical black and white kinds of colors. Sometimes, if you were lucky, you might have orange. And it had huge floppy disk drives, as you can see just there in the front of it. It did have a few ports on it for connectivity, for different kinds of connectors that would allow you to potentially copy data around or move data from one system to another. But essentially, it wasn't very connected to anything. In today's money, that machine, if you were to buy it new, converted for inflation and everything else, taking it into account, would cost you about $4,000, maybe a bit more dollars, brand new, taken forward to today. Which, of course, in contrast to something like the iPhone, the first iPhone that came out in, say, I think that was 2007-ish. That machine was not very expensive comparatively, because of course it was mass produced. It had a mass produced components within it, and those components were of course produced in a much cheaper and efficient way, and they could store a lot more information, and you could do a lot more things with it. You could not only use it as a computer that could do a way more than this poor old thing from the 1980s, right? But as well, of course, it had massive amounts of processing capability and RAM and ability to do things in many different ways than you could use the Osborne One for. But remember, between those two places, this was the starting point. And therefore, if we think about hardware limitations at the time, that was a driving factor about how we worked with, how we thought about data, and how we played with data. And it doesn't matter what industry you're in, those factors, those limiting factors, affect you just like anybody else, especially if the business you're at has been around for a long time, because it's brought a lot of that older equipment and sort of baggage, if you want, with it. So it's no surprise then that if you want to go and look at systems today in any long-term business, you might find something that looks very high level anyway, a bit like this. You've got various databases all over the place. You've got various data warehouses. You might have connectivity between them that have been created for bespoke connections between those systems. You might have software as a service added in, which allows it to grab something from somewhere so that somebody else can make use of it. It's a bit spaghetti-like. And it's no surprise, because in order to present something that looks like a banking app to your screen, you might find that behind it, for many long-term businesses like a bank, this is really the reality of what's underneath it. And it's fine. It still serves what they need. But of course, it's never going to give you that sort of full-blown, reusable piece of information, which has only really been stored in one place and is continuously being updated by context as the multiple channels of the customer contacts you through, like phone, mobile, email, all that kind of stuff. It's just never going to really provide that, because there's just so many places that you have a version of the data that's less complete than somewhere else. And there's lots of systems that aren't looking at that same sort of context of the individual. And that's really one of the major factors that's driving many of our financial services customers, but lots of other kinds of customers too, to rethink for the modern age, for this century, the kinds of architectures that they want to adopt. So I'm going to actually quote a gentleman called Neil Avery, who was at one time at Confluent, and he wrote some blogs way back in the early 2010s, I think. And I like this quote, so I thought I would borrow it. I'm sure he doesn't mind. And I think it's worth reading it out. It says, key realization for the adoption of event-first thinking is that an event represents a fact. Something happened. It is immutable, indisputable. It took place. And we can track that. We can capture that. And if we do, then it should allow us to really consider differently how we think about the domains and the models that we build for managing our data and looking after decisions that we are going to be making from the data we have access to into the future. Now, I will say I tend to modify this slightly for the audiences today, because I think it sounds a little bit better if I just tweak the end of it to say it will enable us to revolutionize the value that we can obtain and pass on to our business, or our business can get from utilizing streaming. And by doing just a few things to get started, by picking a few projects, but keeping an eye on not just the tactical, but the vision and the strategy for the future of the business to move towards a different way of working with data, then you can really revolutionize what can be done for your businesses. So it's no surprise, I'm sure, that actually several thousand companies across the world utilize Kafka and Confluent as the center of their services. And of course, I'm talking mostly and primarily about financial services today. So the majority of the logos here have something to do or in some way interact with financial services. Many of them are banks. Oh, I can just see there's something wrong with one of those there somewhere. Let's see if I can change that. Hang on a moment. Oh, there we go. Thank goodness. Obviously, Credit Suisse recently, that acquisition, as everybody knows, into UBS, but they're still effectively a separate entity, and both of those companies are users of Confluent, so therefore it makes perfect sense to have them both showing up on the screen. If you want to, after watching this webinar today, have a bit deeper dive on the kinds of examples that we've selected from our various customers around the world, anonymized, of course, of how they utilize our capabilities, we have created a white paper, and if the slides, we'll supply these slides at the end for you to use again in the future. You can click on the white paper link here, and you can see examples of all of these types of things that we've gathered. It's also worth mentioning at the end of the slides, I've also created a slide that shows you links to our website where you can follow through on examples directly off the website, additional ones to what's in the white paper, as well as even examples that you can get from GitHub to try them out in Confluent Cloud, should you want to experiment. So we've talked a lot about evolution. We've talked a lot about the way that people or companies evolve their systems. So in the same way, when we think about event streaming, many companies have been on an evolutionary curve for a long time, right? So the first kind of use cases to do with streaming and Kafka and event stream processing capabilities on top of the Kafka and Confluent streaming platforms might have simply been about bringing the data together to get lots of stuff from somewhere and bring it together, or even migrate data from older systems to newer systems. And they might have just been passing that through Kafka or Confluent in order to do it. While passing it through, a lot of people will do things with that data to change the shape of it, to transform it, to maybe do some extracting and transformation and even modification of the format of the data, maybe changing some of the columns or changing the names of the columns to make it all fit into where you want it to go. And those things are very commonly done in the stream. And it's okay, that's data management of sorts as the data's in flight, getting it to where you want it to go, making some changes along the way. But in addition to those things, you can also, if you wanted to in the stream, start to look at patterns of what's going on with that data, especially if that data is data that's updating continuously, or if some of it is. Some data moves slower than other data. So, for example, information on customers, where they live, their phone numbers, what kinds of cars they drive, that sort of thing, isn't maybe going to change all that often. So I think of that as slow-moving data. Yes, most people might think of that as batch data, but I don't. I think of it as data that changes just very slowly. Whereas when people might be logging into their app, that's obviously something that changes all the time. You might log in lots of different times a day, lots of different things happening in the account when you go in and do things with your app. And obviously you might be paying things, transactions. And if you think about that, well, those could be happening all the time, right? People have direct debits going out to their accounts all the time. People are paying people all the time at shops, online, as we discussed earlier, with all of the different capabilities and digital channels available to them. So why not then, if you're already doing work with the data in the stream, if you've put a streaming platform in place, why not then utilize the capabilities that Confluent and Kafka provide to enable you to sort of stick your head in the stream and start to look at the patterns that might be taking place in there. And when they are taking place in there, perhaps start coming up with insights that you can use to benefit you and your customer. Especially in the UK banking market, we have consumer duty, consumer-centric thinking towards solutions and capabilities. Well, that's the perfect place for you to start thinking about that right at the beginning, right at the early stages of the data's inception, making decisions earlier on and maybe gathering insights and passing it on as soon as possible to create really valuable context around what context do I have about my individual customers right now based on what I know is going on in the system that they're utilizing. And that's quite a common place that people do start to think about adopting more insights gathering within the stream. Then you've got sort of levels 4, 5, and 6, and of course, increasingly complex ways that you might be working with the streaming data. So you've got things like probability indicators that you could create or risk indicators you could create that give you some kind of continuously scoring values that might be associated with entities. So you don't have to keep lots of information about the entity in memory, but you might keep some kind of score, and that score gives you a confidence level about how probable it is that it's them that's doing something, perhaps. And then you've got the next level up where you might start to think about taking the data that is available to you in the stream, perhaps inside a data product, and passing that data product data into in analytics models that you might have built in an analytics engine somewhere. Maybe that's a Databricks or some other capability that you might have, or Data IQ, that kind of thing. And maybe you built the models there and you want to attach them to the stream. So you might connect them with container capability and then flow the data through it, sort of inferencing or scoring kind of capabilities. And then you've got the next level up, which is actually where you might be training those models directly from data products that you've created in the stream. So this is building data products or structures of data in the stream that allow you to automatically pass the data into your analytics engine. So your analytics engine can be training continuously over time as the changing data takes place. And then you can start to compare the models that it's generating there with the ones that you're currently using. And then, of course, you can challenge, challenge those models to see if maybe the newer one is more relevant because it has a higher level of probability or confidence about it being more accurate. And this can happen because, of course, a lot of the data around the edges might be changing over time. The kind of habits that people have might be changing over time. So you might want to always be checking, is the model still good? And what about these other models I've got? Could they be better, right? So that could be one way of doing it. And then in here somewhere, of course, we always need to mention Gen AI today, don't we? So you might take advantage of something like generative AI, and you might actually have that subscribed in some way or connected in some way to pass information onto it. It could give you further insights back, which could give you even better context around the patterns that's being displayed from what people are doing in the stream. So all of those things are possible. And it just depends where you might be on the curve. Maybe have a think about where you are on the curve. Have a think about where you'd like to get to. What's the vision for your business? And what's the strategy around how you're going to get there to compete with your other companies that work in the same sectors as you, perhaps. So when I talk about sticking my head into a data streaming platform and looking at the data to try and identify things, I'm really talking about stream processing. And stream processing is a concept that is not itself new. It's a way for you to look at what's going on with lots of data that might be in motion. And while it's in motion, you might use, say, for example, one of 3 different methods to get to that data from Confluent. You might use Kafka Streams, which is a programming capability in Java that would allow you to build lightweight analytics capabilities if you want to analyze the flow of the data and to pass information on perhaps to applications or to other things for consumption and use. You might build something in KSQLDB, which is a way to use SQL-like syntax to look at the stream, do some analysis of it, and generate new data products as a result that you can pass on again downstream. And then in the most recent times, especially in Confluent Cloud, you might want to look at taking advantage of the newest capabilities we've added, such as our Flink in Confluent Cloud capability, which we'll come back to. So for all of these things, I like to think about how I need to, in my mind, imagine the way I would work with this data. And so this diagram helps me a great deal when I'm trying to think about how data flows inside a data streaming platform, how I might build and derive intelligence from it, and how I might build something like a data product that could then be used by something else, maybe something to subscribe to it. So if I think of it this way, it's very simplistic. I've got my connector capabilities. This is me connecting to something. Confluent has over 100 or so, and adding all the time connectors, which are pre-built and available to you to use to get to various different types of databases, applications, other kinds of capabilities. And you can also build your own connectors from pre-built sort of generic ones. You can then tune them and change them to build them to point at other systems that maybe are not automatically provided for by the default connectors that we have. Once you've connected and you've pulled the data into Confluent, you have the ability to then put in place governance. And you have, of course, schema management, which many of you may have heard of before, and allows you to define the schemas for the topics or the data that you're going to consume, I should say. And you can create these objects called topics, which are different ways for you to split the data up within the stream. So perhaps you have, topics that come from one database. In other words, it could be perhaps a combination of data information from different tables in the database that you've decided to load into a single topic. Maybe that topic's called customers. You might have another one called transactions that's coming from maybe an application that people are using to transfer money around. You might have other topics built around totally different structures, but you're going to create those topics and you're going to create schemas, and those schemas are going to help you manage those topics, but you're also going to create rules for obscuring the data, for managing the data, how people might use the data, and so on. And that's sort of governance and lineage that you can put in place in the data streaming platform to help you look after that data going forward. And of course, then what do you want to do with that data? You're going to want to take that data and you might want to derive something more useful from it. So that's where the processing comes in. This is where you might use Kafka Streams, you might use KSQLDB, or you might use Flink to help you analyze those topics, join them together in different ways. Perhaps you would do pattern matching. You might look for, let's say if it was fish in the stream that you're looking through, you might say, well, you know what? I want to find all the brown fish, but only if they've arrived after 3 bluefish, and only if those bluefish arrived after 2 minutes since it saw the last redfish, right? That's just an example, right? But those give you windowed temporal levels of analysis on the data, which you just can't do if you're doing it at the other end of the chain, right? Then, of course, you might derive from that, having put them through that processing capability, you might derive from that a data product that your team are the curators of. You own and curate that data product, and you make it available, and perhaps people can request access to it for different things that they want to do. You can choose whether that's relevant to them and which things within that data product they're allowed to see. And you can then make it available to them via methodologies such as sharing, and then, of course, downstream systems that can then subscribe. Some of the things that might subscribe to your data products might be right back at the beginning. You can see there's an arrow there that goes right back to the beginning system of record in this example, but that could just as easily be something like a watch list. So perhaps if you're building a stream like this to manage, say, fraud activity, or you're trying to track what looks like fraud activity, perhaps what you would do if you flag something as thinking, oh, that may be slightly suspicious, let's see what happens next time. Well, perhaps you could put that person or something about that type of transaction into a watch list. And then the next time you see that type of thing or that person, you can put them through a slightly different path to make it a more in-depth discovery about them. So you don't have to do all of that detailed analysis on the data at the very beginning when in the original flow, but maybe the next time you see that pattern, which could be another way for you to break up the amount of processing that has to happen in order for you to get and derive more detailed and useful insights. So there's several ways you can think about that at a higher level. So this diagram, once it finishes building, I think really does cover that quite nicely. Right at the far left-hand side, we have connectivity to various different systems, different sources, different things that collect data, and we are collecting the data from those, and we're passing them through Confluent in the data streaming layer, the data streaming platform. And in doing so, we're putting them into order, into topics, into schemes that we can lock down and we can manage. And then we're creating and deriving data products. That's this piece here. These data products are derived. They're like complex events in CEP, really, aren't they? They're things that you've enriched, you've built something more complex from the base data at the lowest level. And having done so, you've derived something much more useful, but most importantly, something that can be used over and over again without having to build it anywhere else. Again, you can just reference it from downstream systems to make use of it for different purposes. And you can even join different data products together to create something even more useful, something more enriched, complex, if you want, in terms of the data, but more powerful and more valuable. And that's, of course, sort of stream sharing type concepts where you share streams between different businesses or different parts of the business to help your downstream systems derive something more valuable as a result. Now, this diagram is a bit busy, so my apologies for that. But when it comes to stream processing, I like to try, and this is an experimental diagram, so it's not been polished by our teams, but you can see I've divided that into process at the top and stream at the bottom. And really, it's an extension of that previous diagram that we were looking at with the same colors, right? So we have the connect topics, we have the govern topics, we have the processing topics that get passed to the stream processing layer. We have the topics that have been built as a result of running the data through the stream processing layer. And then, of course, we have the topics where we've shared them, we've made them available for things downstream. And the real reason I wanted to show you this is because I do think of it as the data streaming platform as a whole piece, but within it, I have access to the streaming layer, which is where the data, the streaming, the connections, the transformations, the preparation of the data takes place, and maybe the sharing of the data takes place. And then we have this sort of layer above, it sits on top of the streaming layer. And that's the bit where we do the processing. That's the bit where we can build data model structures inside Flink, for example. And those structures could be looking at things in a very different way. Perhaps we're a bank, perhaps we're wanting to break down and look at a structure like maybe it's our trading book risk structure or something, which this could easily be. And perhaps we're doing calculations at each of these different layers that allow us to get some kind of immediate values about what the risks might be at those different levels of the structure. And then we might forward those back to build, and that build level makes it available for sharing, right? So that's that whole life cycle just split out between process and stream, just to hopefully make that a bit clearer. So back to that diagram we saw, and just to remind you, we were looking at that process piece, which is above the stream, which has within it the governing capability, and the combination of those things, creates us our data products. And those are the things that really allow us to take full advantage of insights gathering on the stream as things happening right away. And as soon as we have something, we can derive value from it much earlier on in the chain than we might have done utilizing data at rest kinds of approaches to designing our architectures. There we see that diagram again, just to remind you that that's the flow and the way that I tend to think of things. So with that in mind, what kinds of examples do our customers have that utilize these kinds of concepts? So for example, if you're looking to build customer experiences that could be derived directly from insights that you're gathering in the stream, you might have inbound data from multiple different challenges that you are subscribed to. You might have inside the data streaming platform, such as Confluent, something like a state vector, a stateful vector, which is holding on to state related to an entity. In this case, it could be a customer. And within that, we've got information that we're holding on to. Maybe that information is giving us just scores, probabilities, way people are behaving, things that are happening. Is that similar to what they might have done previously? Giving us insights. And then we're passing that information on, making it available, sharing it with the different parts of our business from the data products we've defined within that customer state. And actually, that's a typical kind of scenario. And it should be no surprise to you that some of our customers, including HSBC in this example, have utilized us to help with their customer experience through the apps and the different channels that customers utilize to get to work with HSBC. Another one that's very common is people might utilize the different sources of data that are flowing through the streaming platform to combine security and fraud operations. This is something that people often refer to as a fusion center or a data-centric design, right? So we're sort of building it around what data we have available, creating intelligence that way, rather than siloed behavior of, hey, we're doing this in cyber, and it doesn't matter whether you duplicate some of those things in the fraud department, you go and do that, right? So then we've got two versions of the truth, and guess what? We're not helping each other because there's two different things that we could be looking for within that data, and actually, wouldn't it be better if we created data products in the stream and then made them a bit more available to those downstream systems to give them even more help in identifying problems with either cyber or fraud? And actually, it's a really good use case because it is very common today. And in fact, it's a massive problem within the banking industry in particular around the world, especially since COVID. And lots of organized crime have been taking advantage of the limitations of the ability for financial services companies to track what's going on right now and understand the context of that compared to looking at things later. And looking at things later is fine, but wouldn't it be great if you could identify patterns and even perhaps predict something much sooner than before? And it's typical, especially in fraud investigations, for someone to have to go around to an investigations team, and they have a very short window in that team to make a decision as to whether something's fraudulent or not. And the only information they've got is very limited and maybe not even in context. They don't really know from the information they've been given anything useful that could really be used to identify it. And that can sometimes mean that they allow things to happen that perhaps they would otherwise not if they just had more information. So it would be no surprise, I'm sure, that customers like Capital One have taken advantage of our capabilities to help them with that fraud capability, with that kind of investigation within the fraudulent activity. And it has helped them in many ways by creating greater satisfaction for their customers in interactions with them, and also within their customer experience too. Here's a example. I'm just going to show you in a moment an example of an architecture of a payments platform. This is one of our largest customers in the world, and they process around 31 billion payments a year through Confluent. And that's a very huge amount of money that goes through our capabilities. So obviously they have to make sure that what is running for them is extremely resilient, reliable, and meets all the requirements they need for regulation and governance. And a typical, and this is our variation, it's a very high level, typical example of the kinds of things that people do with us for payments processing. Typically, we are subscribed to the messages as the payments are taking place from wherever they're going to and from. But that's actually facilitation. We're part of that, making sure that all the other systems are receiving the right updates in the right timely manner to ensure that the best possible outcomes take place. So it's no surprise that really what this diagram is showing you is us connected to all the sources coming from the payment rails and going out to the payment rails. And at the same time, we're creating data products that really sit in that business applications layer, which are forwarding, or if you like, making available data of more complete information or more composite information, data products for those downstream systems to consume. And that's a very typical example for you there. And you can see very common types of payment methods being used in that flow. And we have connectors for many of those, and a lot of our customers take advantage of those in order to make the best possible insights gathering in the moment from the transactions as they take place as they possibly can. I'm sure it's also no surprise to many of you. I'm sure you've heard of 10x. There is a video here. I won't play it today, but when you get the slides, you're welcome to press that button to play it for yourself to have a look at. 10x is a software as a service banking platform and very successful in the banking space, especially in the digital native banks. And they, at their core, take advantage of Confluent to help them not need to focus on making sure Kafka is running for them. We do that for them so they can focus on delighting their customers with the best possible banking platform services. Euronext is another one of our customers in Europe that takes full advantage of Confluent platform to ensure that their trading platform, which processes many millions of events per day, joining together lots of different exchanges from around Europe to ensure that they have fully reliable, fully resilient, and up-to-date information available all the time for their customers to consume and take advantage of. It's actually worth mentioning that that one also has a video on our website, and I think if you click on here, I've created a link to it so you can also watch it from the slide. One last example, I think, there might be more, but one more I remember being here is a very large financial assets manager in the United States who had been collecting clickstream data for many years, utilizing some, let's say, slightly older products from almost the previous century, which was fine, it was working, but it took them between 48 hours to 72 hours to be able to really analyze things like what their customers needed from them, whether they were getting them the right information in time for their trades. So once they implemented Confluent, they were taking decisions that were taking that long now take place in less than 3 seconds from the initial contact on the clickstream. So customer clicks on something, within 3 seconds, we have a response that is more valuable, and the analysis is already flagged as something that they can take advantage of to help ensure that customer gets the best outcome as a result. So really powerful message from that customer. Few more examples of architecture design for you. We talked about machine learning a little bit earlier on. So this diagram here just helps you get a better sense of what we're talking about here. So you can build models from the stream, you can score models from the stream. In many cases, people often refer to scoring as inferencing. I think of that as being the same thing. I'm sure that's not what a lot of people would say, but essentially it is similar. They are the operational version of a model that you've built offline from the data. But of course, in the modern era, you can also build those models live as the data is in flight. Why not? Obviously, if you do this, if you put these things together, you can build really powerful, insightful systems. And some of our customers, some of the most advanced customers on that curve that we have built some incredible intelligence from the data that they stream through to delight their end users and give their customers a much better outcome for things like their trading portfolios and other things that matter massively to them. And I'm sure it's no surprise that we also are utilized in many ways to help with unlocking access to data, usually in a mainframe, There's various different ways of doing it and getting that data into Confluent Cloud and then utilizing Confluent Cloud to help you transform it and get it ready and create, if you want, data products for downstream consuming systems to be able to use. And you can do it in a way that reduces the costs of how you might have done it elsewhere within the flow architecturally. And there are documents and links to examples on our website that you can use to understand a little bit more about the detail of how you might take advantage of that kind of mainframe data unlocking. I already mentioned fraud and cyber, but this slide particularly just reminds everyone that it's a very common use case that we might be put in front of. Downstream consuming systems that are used for fraud investigations, and those systems could in fact be better informed by us playing with the data in the stream, reducing that data down to just the things that really matter to them, helping perhaps save a little bit of money in storage in those downstream systems, but also in indexing and processing, and therefore giving them much better outcomes in terms of searching for data and also the costs of running everything. So it's definitely worth investigating. And then finally, and this is one you can click on as well. If you click on this slide when you get a chance, you can watch a recording of a webinar presented by Ryan James, who's the CEO of Vitality, for one of the most interesting insurance, finance, and IoT-linked use cases I think I've come across in many of the years I've been involved in IoT-type use cases. And I would say it's one of the first times I've actually seen the company really show monetized benefits from linking those three things together in a way that gives not only them as a company really powerful capabilities and insights and services, but also the customers that they serve as well. So it's definitely worth watching that video if you get a chance. Finally, I did mention there would be some links in the slide that you could click on. These two graphics here, if you click on them, they will take you to our website, and you will see that there are different use cases that you can explore, especially in the financial services space. And although this whole session is, of course, focused on financial services primarily, many other use cases exist on our website for other industries that you might want to go and look through as well. And actually, that's never a bad thing, because you can often find use cases in other industries that nobody's thought to think about utilizing in your industry, but could actually be really powerful from a cross-pollination perspective. It's never harmful to go and have a look to see what other people do in other parts of different industries. So thank you so much for taking the time to watch this today. I hope it's been useful. I believe there might be somebody who can do some questions and answers for you following me later. But if you would like to get in touch with me directly, you're welcome to do so. I've put on this slide my email address, my Twitter handle, and my LinkedIn profile. You're also very welcome to go to confluent.cloud, where you can log in and take advantage of free usage of the confluent.cloud for a period of time while you play and experiment. And remember to go to confluent.io if you'd like to look at those use cases and find out more information. Thank you very much for your time today. I do hope that's been of use, and I'll look forward to perhaps doing another follow-up in future, and perhaps I'll even see you at a future event. Thank you very much indeed. Bye-bye.